Hi friends, welcome to all. In this video we are going to see the packet tracer activity Troubleshoot Multiarea OSPF version 3. Before coming to this activity, friends, if you like to get my future uploading video info directly into your Gmail, you can subscribe this channel right now. Well, coming back to our activity, here we can see our addressing table. Also, we will go through the objectives. Troubleshoot a multi-area OSPF version 3 network. Also, we will go through the background here. A large organization has recently decided to implement a multi-area OSPFv3 network. As a result, the network is no longer functioning correctly and communication through much of the network has failed. As a network administrator, you must troubleshoot the problem, fix the multi-area OSPFv3 implementation, and restore communication throughout the network. To do this, you are given the addressing table above showing all of the routers in the network including their interface IPv6 addresses. You are told that in area 1, R2 is unable to form OSPF adjacencies. In area 0 and area 2, 3 routers, that is AB R2, R3 and R4, have not been able to form OSPF adjacencies. Lastly, ABR1 and R1 have not received default route information. Yes, that's a scenario here. So we will come one by one. Coming to part 1, use show commands to troubleshoot OSPFv3 area 1. In part 1, using the particular symptoms of network failure reported in the background or scenario, begin troubleshooting configuration settings at the routers in area 1. Coming to step 1, check the R2 configuration in area 1. Because R2 is not forming an adjacency with R1, console into R2 and check its interface IP address configuration and its multi-area OSPFv2 configuration. Use the show running config command to view the configuration. Coming to our topology, here we can see area 1 and the routers R2 and R1. Here they say that this R2 is not formed an adjacency with this router R1. So here we are going to verify that on this router R2. Coming to CLI, here we are going to give show running config and we are going to verify the details. Coming to the show output, here we can see in our addressing table, here is the device R2 and here we can see 2 interfaces, that is gigabit Ethernet 0/0 and loopback 1. We will check the IPv6 address with our addressing table. Here we can see interface loopback IPv6 address. Here we can see that. Here it is. So we can match with our addressing table. Here we can see that it's correct. Also we can see IPv6 OSPF10 area 1. Yes, it's correct. Also we can see the interface gigabit Ethernet 0/0 and here we can see the IPv6 address. Here is that. It's correct. Also we can see IPv6 OSPF10 area 1. It's correct. Is R2's OSPFv3 routing process configuration present and correct? Has OSPFv3 been activated on the gigabit Ethernet 0/0 and loopback 1 interfaces, and have they been set to the correct area? Yes, we had seen that. Here we can see IPv6 router OSPF10. Also we can see the router ID, and coming to the interfaces, here we can see loopback 1 and here we can see IPv6 OSPF10 area 1. Yes, is correct. And coming to G0/0, here we can see IPv6 OSPF10 area is 1. Yes, here we can see at R2's OSPFv3 routing process is enabled and the interfaces are configured for area 1. Coming to B, if R2's OSPFv3 configurations are correct, it is possible that OSPFv3 has not been configured on the R1 G0/0 interface. Console into R1 and issue a show running config command to check the G0/0 interface for the IPv6 OSPF10 area 1 configuration. Is R1's OSPFv3 routing process configuration present and correct? Has OSPFv3 been activated on the G0/0 interface and set to area 1? We will check that. Now we will come to the router R1, and here we are going to give the command show running config, and here we can see IPv6 router OSPF10. Also we can see the router ID, and here we can see loopback 0 address, and here we can see IPv6 OSPF10, it's area 1, it's correct. Now we will come to G0/0. Here we can see IPv6 address. Also we can see IPv6 OSPF10 area 1. It's everything correct. Coming to C, it is possible that the hello interval and dead interval timers have been altered from their default values of 10 seconds and 40 seconds respectively. A timer mismatch can cause the routers to not form adjacencies. If the dead interval timer is not 4 times the value of the hello interval timer, that could also cause the routers to not form adjacencies. Check the hello interval and dead interval timer values on R1 and R2 routers. Using this command, show IPv6 OSPF interface G0/0. Is there a mismatch or incorrect configuration on either the R1 or R2 hello interval or dead interval timers? We will check that. Coming to the router R1, here we will give the show command, show IPv6 OSPF interface gigabit Ethernet 0/0, and we will check for the hello and dead intervals. Here we can see that hello 10 and dead 40. So here we can see this dead interval is 4 times of this hello. It's correct. Now we will come to the router R2. Enable, here we are going to give show IPv6 OSPF interface G0/0, and we are going to check the hello interval and dead interval timers. Here we can see that here they given hello interval 20. So we had seen with the R1 the hello was 10. We will check that here. Here we can see that it's a hello 10, but here we can see a mismatch, it's hello 20. So we have to set about same values. Also even we can see this dead timer interval is incorrect. Usually this dead interval timer is 4 times of this hello interval timer. So actually they set here incorrectly. Yes, so here we can see a mismatch as well as an incorrect configuration on this router R2 interface gigabit Ethernet 0/0. Coming to D, correct the hello interval and dead interval timer configuration errors on R2. Right, we can do that. If the problem has been corrected, a syslog message should appear in the R2 console showing an OSPF adjacency change from loading to full. State if the problem has been corrected, and if so, what is the neighbor address. Yes, we will implement this command and we will check that. Coming to the router R2, configure terminal, we have to go to the interface gigabit Ethernet 0/0. Here we are going to set IPv6 OSPF hello interval 10, also IPv6 OSPF dead interval 40. Here we received a syslog message, process 10. Yes, here we can see neighbor address at 1.1.1.1 on G0/0 from loading to full, loading done. Hence here we can see a successful adjacency change. Now we will come to step 2. Check the router configurations in area 2 starting with the ABR2. Coming to A, because it was reported that routers ABR2, R3 and R4 were all unable to form OSPFv3 adjacencies. Console into the ABR2 border router to see why it is unable to form an adjacency with the ASBR router. Is ABR2's OSPFv3 routing process configuration present and correct? Has OSPFv3 been activated on the S0/0/1 and G0/1 interfaces, and have they been set to area 2? We will check all these configurations now. Coming to ABR2 router, show running config, and we will check the details. Here we can see the interface G0/1. Here we can see the IP address. Also we can see IPv6 OSPF10 area 2. Yes, it's correct. Now we have to come to serial. Where is that? Yes, serial 0/0/1. Here we can see IPv6 address. Also IPv6 OSPF10 area 0. Configurations are correct. Here we can see those interfaces in our topology. Here we can see the interface gigabit Ethernet 0/1 which is in the area 2. Also we can see the interface serial 0/0/1 which is in the area 0. Coming to the other configurations, here we can see IPv6 router OSPF10, but we cannot see any router ID set here. No router ID. Hence here we can see ABR2's OSPFv3 routing process has been enabled, but a router ID has not been set. The interfaces have been configured correctly. Coming to B, OSPFv3 requires the presence of a 32-bit dotted decimal router ID. Because ABR2 has no IPv4 addresses assigned to any of its interfaces, a router ID needs to be manually configured. Configure ABR2 with a 6.6.6.6 router ID. So we will configure this. Coming to ABR2, configure terminal IPv6 router OSPF10, and here we are going to set the router ID 6.6.6.6. If the problem has been corrected, syslog messages should appear in the console showing OSPF adjacency changes from loading to full. State if this is the case and what neighbor NBR addresses appear. So we will check that. Here we can see we received 2 syslogs here. Neighbor 7.7.7.7 on serial 0/0/1. And also we can see neighbors 3.3.3.3 on gigabit Ethernet 0/1. Coming to C, on ABR2, a syslog message showing an adjacency change from loading to full with neighbor 3.3.3.3 means that R3 is now participating in the OSPFv3 area 2 process. Check that R4 has provided route information for its connected networks to the OSPFv3 topology database. Using this command, show IPv6 OSPF database. So looking at the output of the show IPv6 OSPF database command, what information would signal the presence of R4? So we will check that. Coming to show IPv6 OSPF database output, here we can see that. Here the router ID 4.4.4.4 signifies the presence of R4 as well as the inclusion of here we can see that the IPv6 address 2001:DB8:A8EA:2C:/64. This is the network address. So here what we can see in our topology. Coming to step 3. Check ASBR for OSPFv3 default route distribution. Coming to A, because ASBR is the edge router, it should have a static IPv6 default route configured. If so, it can distribute that route using OSPFv3 and a default information originate command. Is there an IPv6 default route configured on ASBR? Does the OSPFv3 routing process configuration have a default information originate line present? We will check that. Coming to the router ASBR. Enable show running config. Here we can see an IPv6 default route. And here we can see IPv6 router OSPF, and we have router ID. But here we can see it does not contain a default information originate line. Coming to B, on ASBR, add a default information originate command to the OSPFv3 routing process by giving these commands. Coming to ASBR, configure terminal IPv6 router OSPF10. Here we are going to give a default information originate. Coming to C, check the IPv6 routing tables of ABR1 and ABR2 to see if the default route was discovered through OSPFv3. Looking at the output of the show IPv6 route, did the router learn of the default route from OSPFv3? If so, list the line or lines that signify this. We will check that. Coming to the router ABR1. Here we are going to give the command to show IPv6 route. Yes, so here we can see that. Also, we will check in the router ABR2. Show IPv6 route, and here we can see the default route. Well, that's all in this packet tracer activity, Troubleshoot Multiarea OSPFv3. Here we can see our completion status 100%. Friends, if you have any doubt in this packet tracer activity, please comment below. Also, if you like my video, give a thumb and share to your friends. And don't forget to subscribe the channel so that you will get latest uploading video info into your Gmail. Thank you.